Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Melani, a student of the Robotics Engineering Technology program. In this video, I will explain the analysis of static and dynamic system applied to our PBL project, which is a line follower transporter robot. This assignment is part of the mid-semester assessment for the static and dynamic course, guided by our lecturer Mr. Ahmad Riyad Firdaus. Let's get started. Question number 1. Identify the biological system in your PBL project that requires static and dynamic system analysis. We identified 4 main biological systems. The robot frames need to support the load statically and respond dynamically. Static, to ensure the frame can withstand the total weight of the components and the transport load, e.g. factory marbles. Dynamic, to analyze how the distribution of force affect the frame during movement, such as when turning or passing uneven surfaces. The motor and wheels generate motion and are dynamic system. Dynamic, the motor provides torque to move the robot. Analyzing the thrust force and friction is essential for understanding its acceleration and movement. The gripper needs both static stability and dynamic force when operating. Static, when holding an object, the system must resist the load without moving. Dynamic, during object pickup or placement, the system experiences acceleration and needs dynamic analysis. And lastly, the load affects both static weight and dynamic motion. Adds extra weight to the robot, static analysis is needed for load distribution, while dynamic analysis helps during acceleration and deceleration. Next is question number 2. Draw a free body diagram FBD of the force acting on one of the bicycle system. This is the free body diagram of the robot and its load. The downward force is the total weight. Downward force due to the mass of the robot and the carried object. The ground passes upward with the normal force. Upward force exerted by the floor. The motor creates a driving force. Forward force generated by the motor, while friction resists motion. Opposite motion acts in the opposite direction of F motor. And last question, determine the unknown force so the system is in equilibrium. For the robot to be in equilibrium, all force and moments must balance. For example, if the robot is stationary while lifting an object with its gripper, the normal force from the ground must equal the total weight. The motor force must balance the resistive force if the robot is not accelerating. The zero torque must match the moment caused by the weight is the object to maintain stability. That concludes my explanation of the static and dynamic system analysis of our line follower transporter robot. I hope this presentation gives a clear understanding of how mechanical force and movement are applied in robotic design. Thank you for watching, and wassalamualaikum warahmatullahi wabarakatuh.